Hello class, sorry this is going to take me a while to put up, but my presentation will be on the gas laws. Like I said, my presentation will be on the gas laws. Ideal gases. The ideal gas law describes how gases behave with changing pressure, volume, and temperature, kind of like Boyle's law. You might want to write that down, it's important. The equation is PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the ideal gas constant, and T is temperature. Here's an image kind of explaining what it is. Non-ideal or real gases will behave in different ways from what ideal gas law is described as. We can quantify this difference using the gas compressivity factor represented by the variable z. You can also think of this gas compressivity factor as the ratio of the molar volume of the gas compared to the molar volume of the ideal gas at the same condition. Gas compressivity. The equation for this is Z equals PV over nRT. Z is the compressivity factor, P is pressure, V is volume, N is the number of mole, R is the ideal gas constant, and T is temperature. If you have an ideal gas Z, Z will be 1 because remember that ideal gas law states that PV equals nRT. So the ratio PV over nRT would be 1 because PV and nRT equal each other. For real gases, the number is not 1 and the deviation can be either positive, Z is more than 1, or negative, Z is less than 1. Understanding gas compressivity. You may wonder why real gases will deviate from the ideal gas law. Gases can exhibit non-ideal behavior due to their internal atomic interactions, such as attraction or repulsion forces during collisions between atoms. However, it's more common to have non-ideal behavior in extreme conditions like high temperature or high pressure. Kinetic molecule theory. The theory is based on the following assumptions. 1. Gases are composed of a large number of particles. 2. These particles move in a straight line until they collide. 3. These particles are more smaller than the distance between particles. Most of the volume of a gas is therefore empty space. 4. There is no force of attraction between gas particles or between the particles of the wall of an area. 5. Collisions between gas particles or collisions with the walls of an area are elastic. None of the energy of a gas particle is lost when it collides with one another. 6. The average kinetic energy of a collection of gas particles depends on the temperature of the gas and nothing else. What kinetic theory has to do with the behavior of a gas? The pressure of the gas results from collisions between the gas particles and the walls of the area. Each time a gas particle hits something, it exerts a force on whatever it hit. An increase in the number of gas particles in the area increases the frequency of collisions and therefore the pressure of the gas. You might want to write that down. It's pretty important. Boyle's law, P equals 1 over B. Gases can be compressed because most of the volume of a gas is empty space. If we decrease the volume of the gas, then the pressure increases, causing more collision. In this image, you can see how the particles are moving slowly, but there's more volume. But in the other one, particles are moving quicker because there is less volume. Boyle's law. There is no change in the speed with which the particles move. They just travel quicker. This means that they hit their surroundings more often. Any increase in the frequency of collisions must lead to an increase in the pressure of the gas. The pressure of a gas becomes larger as the volume of the gas becomes smaller. You might want to write that down. It's pretty important. Boyle's law, then, when heat is added. If we have a perfect gas of a given mass of a constant temperature, that the pressure of the gas increases, the volume of the gas decreases, and if the pressure decreases and the volume of the gas increases, the pressure varies inversely to its volume of a constant temperature for a perfect gas. Here's an image. When heat is added, we could see that the volume is increased, but then when more weight is added, the volume decreases, and then when the weight is taken out, the volume is back, like it just adds up more. And we can see that the pressure and the volume is constant. Alright, Charles' law. B1 divided by T1 plus 273 equals V2 divided by T2. The average kinetic energy of the particle in a gas is proportional to the temperature of the gas because the mass of these particles is constant. The particles must move faster as the gas becomes warmer. You might want to write that down as well. In this image, we can see that the temperature isn't that high up, but the particles are close together. But when the heat is added, the volume increases. Charles' law. If they move faster, the particles will exert a greater force each time they hit surroundings, which leads to an increase in the pressure of gas. The area will expand until the pressure of the gas balances the pressure of the atmosphere. The volume of the gas therefore becomes larger as the temperature of the gas increases. You can see this in the image because the volume increases as the heat increases. Here's an example. A bubble of air trapped in a pool of water has a volume of 1.20 centimeters cubed at 24 Celsius. Calculate the temperature in Celsius of the air bubble when the volume became 1.26 centimeters cubed. So we know that the formula is V1 over T1 equals V2 over T2. So you plug that all in and you multiply 24 plus 273 and 1.26, and you divide it by 1.2, and you end up with 311.85 Kelvin. Obviously, we have to make that into Celsius, so you subtract 273 and get 38.85 Celsius. Subtract minus 273 because 0 Kelvin is negative 273 Celsius. Gay-Lussac's law. Gay-Lussac's law states that the pressure of a given mass of gas varies directly with the absolute temperature of the gas when the volume is kept constant. So the formula is P1 over T1 equals P2 over T2, where P is pressure and T is temperature. And here is an example. A gas has a temperature of 103 at 25 Celsius. What will the pressure be when the temperature reaches 928 Celsius? Well, we know that the pressure is 103, and we know that the temperature is 25, but you have to add 273 and you get 298 Kelvin. And we're looking for the pressure, and we know that the temperature is 928 Celsius plus 273, which is 1201 Kelvin. So what we do is multiply 103 and 1201 and divide by 298, and we end up with 421 being the pressure. The combined gas laws. The combined gas law combines the three gas laws, Boyle's law, Charles' law, and Gay-Lussac's law. It states that the ratio of the product of pressure and volume and the absolute temperature of a gas is equal to a constant. You might want to write that down. It's also important. Boyle's law is PV equals K, Charles' law is V over T equals K, and Gay-Lussac's law is P divided by T equals K. And all that combined is PV over T equals K. Combined law example. If the volume of an ideal gas collected at 0 Celsius and 100 kilopascal is 50 centimeters cubed, what would be the volume of 60 Celsius and 108 kilopascal? We know that the temperature is 0, so you add 273 and get 273 Kelvin. We know that the pressure is 100 kilopascal, and we know that the volume is 50 centimeters cubed. And we also know that the temperature will be 60 plus 273, which is 333 Kelvin. And we know that the pressure is 108 kilopascal. What is the volume? Well, you plug it into the formula up top, and you end up with 56.5 centimeters cubed. Just remember to use the formula up top. And here is my works cited page. Thank you.